Students, in this lecture also I'll be discussing about the 8086 microprocessor instruction set, and under arithmetic and logical group the next instruction that I'm going to discuss is related to the multiplication operation. So in 8086 microprocessor, for multiplication operation we use the instructions MUL and IMUL. So let's see what MUL instruction does. It is for multiplication. So using this instruction we can perform 8-bit multiplication or 16-bit multiplication. The format for writing the instruction is MUL source. For example, MUL BL. What does this instruction do? It performs, since here BL is a 8-bit register, it will perform 8-bit multiplication between the mentioned 8-bit register, that is the content of BL register, and the content of AL register. So the multiplication operation will be performed between BL and the AL register, that is their contents, and the result, which is obviously more than 8 bits, will get stored in the AX register. Similarly, using this MUL instruction, we can perform 16-bit multiplication. So for 16, let's take the example of 16-bit multiplication. So for example, MUL BX. So obviously BX is a 16-bit register. So what does this instruction will do? It will perform 16-bit multiplication between the content of 16-bit register so mentioned and the 16-bit accumulator. So the result obviously will be more than 16 bits. So how the result will get stored? The result will get stored in such a way that MSB word will get stored in DX register, and the LSB word will get stored in the AX register. Therefore now, and this is for this multiplication, this MUL instruction, we use it for unsigned numbers, unsigned byte or unsigned words. Flags affected, auxiliary flag, parity flag, sign flag, and zero flag will get affected during this operation. Then we have IMUL instruction. This is also for multiplication operation. It will work in the same way as the MUL instruction. IMUL, if we perform 8-bit multiplication using IMUL instruction, obviously how the 8-bit multiplication will occur? The 8-bit multiplication will occur between the mentioned register. The format for writing this instruction is IMUL source. So the 8-bit multiplication will occur between the mentioned 8-bit register and the accumulator load, that is AL, and the result will get stored. Obviously it will be more than 8 bits. It will get stored in this AX register. Similarly, if we want to perform 16-bit multiplication using IMUL instructions, so how the operation will happen? It will be like multiplication between CX register pair, that is the 16-bit register mentioned in the instruction, and the 16-bit content of this AX register, and the result will obviously be more than 16 bits, and it will get stored in such a way that higher word will get stored in DX and lower word will get stored in AX. So it will work in the same way as MUL instruction. Flags affected here will be carry flag and overflow flag. The only difference between IMUL instruction and MUL instruction is this: MUL instruction is used for unsigned byte or words, and whereas IMUL instruction is used for signed byte or word. Now the next instruction or the next operation that we are going to talk about in 8086 microprocessor is division operation, and the instructions that we are going to use for this operation in under 8086 microprocessor are DIV and IDIV. So DIV and IDIV will work in the same way. Both will work in the same way. The only difference is that DIV instruction is used for unsigned words and IDIV is used for signed words. So how this instruction will work? Let's take the example of div. The format for writing this instruction is div source. So what it does, for example, divcl. So it divides, and div, what it does, it divides an unsigned word by a byte, or divides an unsigned double word by a word. Flags affected, here all flags are undefined. So as I've taken the example divcl, what it will do, it will divide the word stored in ax, that is accumulator, ax 16-bit accumulator. The word stored in 16-bit accumulator will get divided by the mentioned 8-bit register, that is by byte, that is byte stored in CL, and the quotient will after division, whatever be the quotient, it will get stored in AL register, and the remainder will get stored in the AH register. So this is how it is dividing a word by a byte. This same instruction can be used for dividing a double word by a word. Let's take an example. divcx. What this instruction will do, it will divide the double word. That is, double word means the word obtained, double word obtained through dx and ax content. So the double word stored in dx and ax will get divided by the word stored in cx, that is the register mentioned in the instruction. So whatever be the quotient after division, whatever be the quotient, it will get stored in ax register, and the remainder will get stored in the dx register. So this is how division operation will work. IDIV, same thing will occur, same operation will occur for IDIV also. The only difference is IDIV is used for signed word, division of signed word by a signed byte, or division of signed double word by a signed word. This is for signed arithmetic. Next instruction is comparison. So comparison, it compares a byte or word from the specified source with a byte or word from the specified destination by subtracting the source or byte or word from the destination byte or word, but the result is not stored in the destination, only flags are affected. For example, let's take the example CMP BL01H. So what here the source is 01H, BL is the destination. So whatever written here is source, whatever written here is destination. What it will do, it will subtract the content of source from the content of register. So it will subtract the source from the destination. It will subtract the source from the destination, and as per the result, the flags will get affected, and then the result will get discarded. The result is not going to get stored in any place. So here source can be an immediate number, like here is in this instruction it is an immediate number. Source can be an immediate number, register or memory location, and destination can be a register or memory location. Source and destination cannot be memory locations at the same time, and source and destination both must be either byte at the same time or word at the same time. Means the comparison should be between either bytes or between the words. So this was about a comparison, and the flags affected are, all flags will get affected, all the 6 flags will get affected, and trap flag, interrupt flag and direction flag, they do not have any relation with the arithmetic operation, so they are not going to get affected. So only the 6 flags will get affected. Now the next group that I'm going to talk about is basic logic instructions. Under this group you will get to see the instructions that are related to the logical operations like AND, OR, XOR, NOT, etc. So let's first talk about the AND operation. Here what is happening, the format for writing this instruction is AND destination source. So what it does, it logically ANDs the content of the source and the content of the destination. It logically ANDs the content of the source and the content of the destination, and whatever is the result, the result will get stored in the destination. So source, again same thing as for every instruction you will come across. Source may be immediate number, register, or memory location. So in 8086 microprocessor, whenever I am talking about source, so source may be immediate number, register, or memory location, and destination may be register or memory location, and both source and destination cannot be memory locations at the same time. Now for example, AND BLAL, what it will do, it will perform AND operation between the content of BL and AL, and whatever is the result, that result will get stored in the destination, that is in BL register. Flags affected. Now for 8086 microprocessor, it is manufactured in such a way that for AND operation, carry flag and overflow flag will be 0. Parity flag, sign flag, and 0 flag will get affected because of this AND operation, and auxiliary carry flag will be undefined. Now the next operation that I'm going to talk about is the OR operation. OR operation. So in OR operation, the instruction that we are going to use is OR destination source, that is format for writing. The instruction is OR destination source. Again, destination source can be immediate number, register, or memory location, and destination can be memory location or register. Both source and destination cannot be memory locations at the same time. So what does this instruction do? It logically performs the OR operation between the source and the destination content and stores the result in the destination. So again, source, destination, and flags affected will remain same as we have studied in this AND operation. So flags affected will be same like in the AND, that is carry flag and overflow flag will be 0, parity flag, sign flag, 0 flag will get affected as per the OR operation, and auxiliary carry flag will be undefined. For example, OR BL AL, that is performing OR operation between BL and AL, and the result will get stored in the BL. The result will get stored in the BL. The next instruction that I'm going to talk about is XOR instruction, and it is like XOR destination source. It performs the XOR operation between the destination and source content. So source, destination, and flags affected will remain same as we have studied in the AND or OR operation. The conditions are exactly the same. Here, for example, XOR BL AL, what does this instruction do? It performs the XOR operation between AL and BL, and the result will get stored in the BL, that is in the destination. Now next instruction is NOT instruction. What does this instruction do? The format for writing this instruction is NOT destination. For example, NOT AL, it inverts each bit of a byte or a word of the destination, and the destination can be a register or memory location. Here flags affected, no flags will get affected. So whatever register is mentioned in the destination, or the content of that register, what this instruction will do, it will invert each bit. That is, if it is 0, then it will get converted to 1. If it is 1, then it will get converted to 0 after this NOT instruction. So it will invert each bit of the content of the register mentioned here due to this instruction, NOT instruction. And the next instruction is test instruction. What it does, it performs AND operation, but it does not store the result in the destination and affects only the condition of the flag register. So flags affected will be same as in AND operation. So let's take an example, test ALCL. What it will do, it will perform AND operation between these two registers mentioned as destination and source, like AL and CL. The content of AL and CL, AND operation will get performed between the content of AL and CL, and as per that the flags will get affected. So the next instruction that we're going to study about is shift and rotate, that I'll tell you in my next lecture. I'm ending this class here. Thank you.